So here's note 17, and here's a word that everyone should know, I hope, Pythagorean. That's from your triangles, right? Triangles, right? A squared plus b squared equals c squared, and that's going to come out in a little bit. So let's see. You already know that the reciprocal of cosine is secant x, the reciprocal of cosecant is sine x, the reciprocal of cotangent is 1 over tan. And what does that mean? That means that you can always do this as well. Sine x is the reciprocal of cosecant, so you can write 1 over cosecant x. Cosine x is the reciprocal of secant, so you can write 1 over secant x, and so on and so forth. Don't forget that cotangent is also x divided by y, or cosine divided by sine, and here it is. I wrote it in a nice little bullet here. And tan is sine over cosine. So cotangent and tan are reciprocals of each other, and there they are. No big deal. Cool or not cool? Cool. All right. So don't worry, guys. It's not a huge big deal. We're just doing transformations. All we're doing is proving properties. So it says here, transform sine x cotangent x into cosine x. So what that means is they want to see sine x cotangent x as just cosine x. That's what they want. If you want to write an equal sign, you may. It's not going to make a big deal. If you want to write an equal sign that you're trying to prove sine x cotangent x equals cosine x, that's pretty much saying the same thing. So here's how you do it. We start off with a very basic one, guys. We know what cotangent x. Look, we have that rule right there, that definition right there. So I'm going to write sine x, and I'm going to substitute what cotangent x is in terms of sine and cosine. So I know that cotangent x in terms of sine and cosine is cosine x over sine x. And it's coming out little wigglies. I'm not sure why it does that sometimes. So there it is. And then when I do that, I have these sine x dudes cancel themselves out because I have one on the top and one on the bottom. If you want to think of this as like sine x over 1, you can. And so there it is. The sine x's cancel out, and you're just left with cosine x. Check mark. So now that we verified that this is true, you can put 3 little dots in a triangle formation, and you can say this signifies that sine x cotangent x is nothing more than cosine x. By the way, these 3 little dots in a triangle formation is the math way of saying therefore. And usually you use that once you've done some logic or some algebraic manipulation, and you've gotten to the statement. In this case, we got our statement that the sine x cancel out, and you just had cosine x by itself. So we have proven that sine x cotangent x is nothing more than cosine x. They're both equivalent statements. They both mean the same thing. Does that make sense to everyone, guys?
Yes.
Okay. All right. I'm getting ready. I'm going to teach you guys something called, okay, this is the unofficial name. It is called the Valentine's formula. And, well, you'll see right now what it is in a little bit. So go to the second page. We're going to draw a unit circle. So here's my unit circle. And the radius of a unit circle is 1. So before I even get started, guys, you should have learned this in geometry and algebra 2, but I realized that we are in a pandemic and maybe you did not cover conic sections. The equation of a circle with radius r centered at x naught comma y naught is, and here it is. I'm going to put a colon and I'm going to give you the equation of a circle. X minus x naught, close it squared, plus y minus y naught, close it squared, equals r squared. Sometimes they call this standard. Sometimes they call this standard. X minus x naught over r squared plus y minus y naught over r squared equals 1. Both are the same, but this is the one that we will be focusing on. And if you've never seen that before, I'm sorry, guys. You know, we should have seen it at least a handful of times. Besides math prep, you should have seen it in a math class like geometry. And I know that I taught it when I taught geometry. I would teach equations of circles and equations of ellipses. But if you didn't see it when you had geometry your freshman year or 8th grade year, hopefully you saw it maybe in Algebra 2, but then Algebra 2 you got cheated because you were in a pandemic. So double whammy for you guys. So if you've never seen it, I'm sorry, guys. If you want to have a lesson on circles and ellipses, feel free to come by one of these days after school and say, Chavez, can you teach me about ellipses and circles? And we can have a lesson on them. They're not hard. They're relatively easy. They come out all the time on the SAT, guys. So it's a very good idea for you to come in for that maybe one of these days. What is x naught? X naught is the x coordinate of the center. So when I have my unit circle, the center is 0, 0. And of course, look, this, I didn't draw it perfect, obviously, right? It's not drawn perfect, guys. So if worst case scenario, this is the only thing you need to know. What is the equation of the unit circle in Cartesian coordinates? X squared plus y squared equals 1 squared, which is 1. By the way, when I say Cartesian, that means in terms of x and y, because later on we're going to be doing something called polar or parametric as well, and parametric, not just polar. Are we okay so far, guys? So this x squared plus y squared equals 1, that's the equation of the unit circle, centered at the origin. So if you were to type that on Desmos, you would get a circle. As a matter of fact, I wasn't going to, but let's go ahead and take Desmos out and you can see. So let me go ahead and share my screen and let's go to Desmos and let's type it in. So let's see what happens, guys. So I'm gonna type in x squared plus y squared equals 1. And there it is, the equation of a unit circle. As you can see, it is a circle with a radius of 1. Cool. If I type in x, well, okay, that's all you gotta know. Let's not give you more information than necessary. All right, let's go back. Now, remember when we talked about the unit circle, when we started talking about these right triangles here, we recognize or remember that this x coordinate was some cosine of some angle, and that y coordinate was just sine of some angle, and where that angle was this one. So I can say, let me see, cosine theta equals x divided by 1, which is just x, semicolon, sine theta is just y divided by 1, which is just y. And you guys remember that. Why is it x? Because remember, cosine is adjacent over hypotenuse. This displacement is an x value. This vertical displacement is a y value, and the hypotenuse is a 1 because the radius is 1. So cosine is adjacent over hypotenuse, so x over 1, x. Sine is opposite over hypotenuse, so y over 1, y. Does that all make sense, guys, to you guys? Okay. So now I can just substitute these guys here. I can just substitute those into this, x and y. So x is just cosine theta, put a square on it, plus, and y is just sine theta, put a square on it, and equals 1. So the right way to write it, I'm going to put a bullet. I'm going to call it number 1. You know what? Forget the bullet. I'm just going to put number 1. Here's your first trig identity, Pythagorean identity. That's what it's really called. Cosine squared, and it's cosine that's being squared, so put the squared after the s, plus sine squared, put the squared after the n, equals 1. And it has to have an argument. So a lot of people just write cosine squared without the theta. It has to have some type of argument. All right, so here's what I want you guys to do. I want you guys to write a poem to your boy or to your girl. You know, we don't judge. So here's what I want you guys to write a poem. Well, maybe during Valentine's Day, because this is called the Valentine's formula. So here's what you're gonna do. You're gonna say, babe. I mean, I don't know. That's how you talk. I mean, I don't talk like that. But if you talk like that, babe, it just sounds so weird. Just call them by their name. Like, what do you got? Okay, anyways, babe, you're cosine squared, and I'm sine squared, and together we are 1. And if they tell you, huh, what does that mean? If they tell you anything of that, just dump them immediately. You don't need any of that. Just dump them, get yourself a new boy or a new girl. If they don't know that, then get them out of there. And I'm kidding, guys. Don't break up with them for that. That's not a reason. Educate them. So there it is. It's called the Valentine's formula. It's not really called the Valentine's formula. The official name is called the Pythagorean identity for trig. But I call it the Valentine formula. So whenever you talk to a professor, do not call it the Valentine formula. And if you do, tell them you come from like Jeff High School or something. Don't say YWLA. All right, so there it is. Now you'll remember it forever. Your cosine squared, your significant other sine squared, and together you guys are one. So I'm going to go ahead and rewrite this. Cosine squared plus sine squared equals 1. And I'm going to get another identity from it. I'm going to divide every single term by cosine squared. Chavez, why are you doing that? I don't understand why you're doing that. Okay, let me tell you why I'm doing it, guys. I want to get another identity. What does identity mean? It just means a property. I want to get another property. If I divide cosine squared plus sine squared equals 1, everything by cosine squared, so then here's what I get. Cosine squared over cosine squared, that's just a 1. Plus sine squared over cosine squared, that's tan squared. And 1 over cosine squared, well, that's just the reciprocal we just talked about right now. That's secant, and because it's being squared, then I got to put a square on it. So that is Pythagorean identity number 2 for trig. So I'm going to vote number 2, and I'm going to write 1 plus tan squared theta equals secant squared theta. So write that down. I'm going to rewrite it again. The cosine squared plus sine squared equals 1. Cosine squared theta plus sine squared theta equals 1. And I'm going to divide all 3 terms again. I'm going to divide them all again by sine squared, everything. Divide by sine squared, divide by sine squared, divide by sine squared. Chavez, why are you dividing everything by sine squared? Because I want another property. Cosine squared plus over sine squared, that's just cotangent. So I'll write cotangent, put a square on it, theta, plus sine squared over sine squared, that's a 1, equals, and then 1 over sine squared, that's cosecant squared. That is my third Pythagorean trig property. So I'm going to rewrite it. Cotan squared theta plus 1 equals cosecant squared theta. What are they called? Let me see if I can write it without misspelling any names. Pythagorean trig properties. If you Google Pythagorean trig properties, these 3 should be the first ones to come out. And if you don't believe me, go for it and Google it. Okay, what's up?
That third one says cotangent, right?
Correct. Oh, it just looks funny, huh? Now let me make it look better. Cotangent squared. All right. Let's see how we're going to use those. So now let's go to this page here. So it says example 2, and don't worry, guys, we're almost done. We're almost done, guys. It says cosine squared minus sine squared into 1 minus 2 sine squared. So what they really want me to do, cosine squared x minus sine squared x equals 1 minus 2 sine squared x. What they want me to do is to confirm this, that cosine squared minus sine squared is 1 minus 2 sine squared. So I want you to recognize that on the right-hand side, you don't have a cosine squared. So I'm probably going to have to substitute something for cosine squared. Well, the only thing I know right now is the Valentine's formula. That's all I know. Cosine squared, and I got the argument as x here. So cosine squared x plus sine squared x equals 1. That's all we know. And I can isolate cosine squared. So here it is, my Valentine's formula. I'm going to move that sine squared to the right. Cosine squared x equals 1 minus sine squared. I haven't done anything yet, guys. I've just been messing with my side note here. This is my side note. I'm going to start doing a substitution. I'm going to drop this Well, I guess you can't really drop it, right? Just write it below it. So here we go. I'm gonna write in parentheses what cosine squared is, but I'm not gonna write cosine squared. I'm gonna write 1 minus sine squared. 1 minus sine squared x, close it, minus sine squared x. Catch up to here. Then what we're gonna do, guys, I have these parentheses and you know, there's nothing in front of them, so I can just drop it like it's hot, like Snoop Dogg says. So we're just gonna drop it like it's hot. They're out. I know that was dumb. I won't say that again. 1 minus sine squared x minus sine squared x. I won't say it again today, guys. I'll probably eventually say it again, but not today at least, because I'm already slightly annoyed by me saying that. All right. How do we feel right now, guys? Are you guys still okay? All right, next. Negative sine squared minus sine squared. How many of those do I have? Yeah, I got 2. Okay, you can't see, but I have 2 students here in front of me, and they both signaled the peace sign. But I knew that peace, I knew that they meant 2, but they didn't say it out loud. But there's 2 of them, so you write 2 sine squared. And there it is. 1 minus 2 sine squared. I put a little check mark. It works. Cosine squared minus sine squared is 1 minus 2 sine squared. So if you want to be mathematical about it, you put 3 little dots in a triangle. Remember, that means therefore. So it's like saying logic. Therefore, cosine squared x minus sine squared x does in fact truly equal 1 minus 2 sine squared x. You can also put an arrow there, but I like the equal sign better. Rubio, you doing all right, Rubio? I'm just thinking, like, I wonder if Miss McLaren, like, okay, Miss McLaren has access to all my videos because, you know, I send the links, and I wonder if she ever watches this and is hearing like me, like, I'm not picking on you, but I'm always like Rubio, Rubio, you know, and I wonder if she watches my tutoring and all that other stuff. Like, I'm just wondering, like, that lady's super busy, so I don't know, but anyways, let's continue here, guys. All right, example 3. This one says prove algebraically. We've been doing that the whole time, but prove algebraically that 1 plus cosine x times 1 minus cosine x equals sine squared x is an identity. So they're already telling you that this is true. So I guess maybe this is the, you know, the other ones were, I feel like they're all the same here. So they're already telling you this is true. They want you to prove it. Oh, I got to go all the way. Okay. If you recognize that these binomials are the difference of squares, then you can just go right ahead, right into it and go 1 minus cosine squared x. If you don't see that, relax. I'm going to FOIL it for you so you can see. 1 times 1 is a 1. 1 times negative cosine x is a minus cosine x. Cosine x times a 1 is a positive cosine x. And then cosine x times a negative cosine x, that's going to be minus cosine squared x. So remember, every time you want to say squared, that sine or cosine is squared, you put the square immediately after the s, because if you put it after the x, it's the argument that's being squared. Either that or use parentheses, guys. All right, now you can see that the middle terms are going to cancel out. Now, some of you already saw that. You're probably saying, Chavez, I know how the difference of squares looks. That was the difference of squares from the beginning. I could have just written 1 minus cosine squared immediately. You're right, you could have. So there it is, 1 minus cosine squared. Now what? Well, from there, I go to the side and I say, well, I know the Valentine's formula, or we know the Valentine's formula. We know that cosine squared x plus sine squared x is 1. That's one of our properties. Our Pythagorean trig properties. So I want you to recognize, so check it out. I could either, if I wanted to, you could solve for cosine squared and then substitute that expression in, but I want to do one better. I'm just going to go ahead and move that to the right. And look what happens. Sine squared x equals 1 minus cosine squared x. I want you guys to observe that I have 1 minus cosine squared on the left-hand side. Well, what I mean by left-hand side is this guy right here. That's 1 minus cosine squared. Well, look what I have here. That's 1 minus cosine squared. I guess I should color code it. Green, green. So what does 1 minus cosine squared equal to? that equals sine squared. It's just a quick substitution. If you don't like that, you can get cosine squared by itself and say cosine squared equals 1 minus sine squared like we did earlier. Substitute it in there and the ones will cancel out and you'll get the sine squared. Cool or not cool? So then I'm going to put 3 dots. Therefore, 1 plus cosine x times 1 minus cosine x is equal to sine squared x. How do we feel? Okay. All right, let's keep going, guys. Example 4, these are actually kind of fun. The example 4 ones. So when you have something like this, this one says cotangent A plus tan A equals cosecant A secant A is an identity. So we got to prove that just like the last one. So I like to work with the left-hand side and make it equal to the right-hand side, guys. So what I would do, I guess first I'm going to write cotangent plus tan A. So cotangent of A plus tangent of A. A is the argument. Argument just means what's inside the parenthesis. Chavez, what parenthesis? There's no parenthesis there. There, now there's parentheses. So what I would do, we want to rewrite cotangent and tangent in terms of sine and cosine. So that's what I'm going to do. Cotangent is cosine over sine, so I'm going to write cosine A over sine A. Plus tangent is sine over cosine, so I'm going to write sine A over cosine A. So catch up to here. You guys okay so far? Virtual class, are you guys all right so far?
Mm-hmm.
Okay. So now what I want to do, guys, don't fall asleep on me. You guys sounded like you guys are getting tired. Don't worry, we're almost done. Now what I want to do, I want to add these two dudes up. So the only way to add these two dudes is to have a common denominator. And you guys have been doing that since you guys were like in 4th grade. So I'm going to multiply this right term over here by sine A over sine A. Common denominator, sine A over sine A is 1. So you haven't changed anything. And I'm going to multiply this left dude by cosine A over cosine A. So now that we do that, here's what we're going to get. We're going to have cosine squared A over sine A cosine A plus sine squared A over sine A cosine A to remain consistent there. And now that I know that I have my denominators are the same, I'm going to rewrite it, and I'm going to write this as cosine squared A plus sine squared A, and all this is over sine A cosine A. So catch up to here. Okay, now what? Now I'm stuck. Where do I go from here? I mean, I'm not really stuck, but what do we do? Is there something in there that looks like something we just learned a little while ago? Do you guys see it? It's the Valentine's formula, guys.
The numerator equals 1.
Yeah, look, this is cosine squared plus sine squared. That equals 1. That's your Valentine's formula. The heart formula. I mean, I guess, yeah, cosine squared plus sine squared equals 1. So here we go. Now we just have 1 over sine A cosine A. And now you're like, okay, now what? Well, 1 over sine A cosine A, that's the same thing as saying 1 over sine A times 1 over cosine A. I just separated them. Now what, Chavez? Well, guys, look. Sine A is cosecant A. And 1 over cosine A, okay, sorry, I said that wrong. Sine A does not equal cosecant A. 1 over sine A equals cosecant A. And 1 over cosine A equals secant A. I'll circle it for good notes. That is cosecant A. This one is secant A. And there it is. We're done. So what have we proved? I put a little triangle. I put a check mark. I like to put check marks. You don't have to do that if you don't want to. I put a little triangle with 3 little dots. And I put cotangent A plus tan A does in fact equal cosecant A secant A. How do we feel, guys?
Good.
Okay. And then the last one, this is about as hard as it gets. It's not going to get any harder than this. And the one that you have today for Delta Math, it's going to be very basic. They're just reciprocal properties, and all they want is as long as it doesn't have a denominator. So if you need help, you can come in. You know, once we stop this, you can try it out, and if you can't figure it out, come in, and we'll help you out with it. All right. So again, it wants us to prove algebraically that this is a property, and we have 1 minus cosine B over sine B. I could have written the right stuff, the one on the right, to prove to the left, but I'm gonna, I like to work from left to the right because that's how I read a book, left to right. So 1 minus cosine B over sine B equals sine B over 1 plus cosine B. They're telling me it's an identity. They want me to prove it. So the way these work, guys, I think the best way for you to understand this stone cold is with experience. Anytime you have something that has 2 terms like this, you have 2 terms on the top and 1 term on the bottom. I think the best way to do it is to multiply by the conjugate. Not always, but to multiply by the conjugate. Now, I don't know. Do you guys remember what the conjugate means? Oh, man. That's what conjugate means, guys. If you have 1 minus cosine B at the top, the conjugate of 1 minus cosine B is 1 plus cosine B. And then some might say, Chavez, conjugate has to be for complex. No, it doesn't. 1 minus cosine B, the conjugate of that is 1 plus cosine B. Now, why am I doing that? Well, I want you guys to recognize, don't worry, you will get better with experience. I want you guys to recognize that these two here are the difference of squares. And when you multiply the difference of squares, I'm going to have 1 minus cosine squared. And 1 minus cosine squared, I can replace that with something because I know the Valentine's formula. Does that make sense? I know the Valentine's formula. We know the Valentine's formula. Cosine squared plus sine squared equals 1. So check it out. Here's what you're going to have. And by the way, before I continue, because I don't want you guys to become robots, this in green, that's just a 1. Look, guys, 1 plus cosine B over 1 plus cosine B. That is just a 1. Anything times 1 is itself. You're not changing anything because you're just multiplying by 1. Does that make sense, guys? Okay. Now check it out. When you multiply the difference of squares on the top, you're going to get 1 minus cosine squared B. Now, if you want to do FOIL, then that's fine. The middle terms are going to cancel out. And on the bottom, do not distribute this. And let me tell you why. You do not want to distribute because I already have the 1 plus cosine B right there. Do you see, guys, that? Do you see that, Rubio? Hey, no yawning. No, I'm kidding. We're almost done. I know you're tired. How do we feel? Do we feel okay? All right. Now look, I have 1 minus cosine squared at the top. I'm going to replace that. I'm going to substitute that with what? I'm going to substitute that with this. This is my sine note. Sine squared equals 1 minus cosine squared B. So I'm going to rewrite this and I'm going to say, well, 1 minus cosine squared B is nothing more than sine squared. So I'm going to write sine squared B over sine B 1 plus cosine B. Is everyone okay? Virtual class, are you guys all right? Is that a yes? I haven't heard you. Okay.
So is it gonna cancel out or no? Because
Heck yeah, it's gonna cancel out. Okay, sorry, I didn't have to get that rowdy there. Yes, it's gonna cancel out. You're not offended, are you, miss?
No.
Okay, please don't be offended. I was just getting like happy, because you're right. It's gonna cancel out. One of those with one of those. And now look, sine B over 1 plus cosine B. Isn't that what they wanted? Oh, that's a cute happy face. I don't know if do them nice, but that one's a nice one. That's what they wanted, guys. I put 3 little dots like in a triangle, in the form of a triangle, and I write 1 minus cosine B over sine B does in fact equal sine B over 1 plus cosine B. And there it is. And that's about as hard as it gets. Now we are going to do harder ones tomorrow, or actually, I guess not. I guess not. We're just going to do them on video, and you guys are going to hopefully take notes and write all that good stuff down. All right, guys, let's all come back.